Data science through data mining. This is very interesting topic. Let us see what is data science. Data science consists of visualization, statistical modeling, statistical computing, data technology, data research, data consulting, real-world applications, and scientific methods. Visualization, that means with the help of the data, what we are visualizing. Statistical modeling, a lot of statistical tools we will be applying on the data, and thereby you come out with some conclusion. And statistical computation, you will be using some kind of probability distribution, thereby you will do some kind of computation. Data technology, and different type of technological tools we will be applying on the data, that is called data technology. Data research, with the help of the data, we can do a lot of research methodologies we can apply, and thereby we can come out with research conclusion. Data consulting, again based on the data, a lot of consulting jobs are going on. Real world applications is very transparent, scientific methods. So based on the data, we do a lot of scientific methods. Again, from the data science, from this figure you understand the data mining is used and various kinds of models are applied. Computing processing is possible. Analytics are going on. Machine learning is there. Knowledge data discovery is applied. Visualization, pattern recognition techniques, statistical modeling. So we are going to focus data science through data mining. So that is the topic, and that is the hot topic today. People are making use of the data mining for the data science applications. Now again, let me talk about the data science a little bit. In the case of the data science, the analysis part is there, and structure of the data we have to study. Based on the structure of the data and analysis, we apply some kind of algorithm, and then after applying the algorithm, we do the processing. The processing is done with the help of the programming. Then you get the conclusion for your problem, namely you are solving the problem, and once you solve the problem, you get the output that is nothing but the knowledge. What is data mining? Data mining is nothing but finding the hidden information in a database, fit data to a model. Similar terms, data mining algorithm means it has got some kind of objective, fit data to a model. It can be descriptive or predictive. Preference, some technique to choose the best model, and search techniques will be used to search the data in the form of query. Database processing versus data mining processing. Let us see. What is database processing? What is data mining processing? Let us compare now. In the case of database processing, the query means well defined and SQL is used. In the case of data mining, poorly defined query, no precise query language is possible in data mining. In the case of database, operational data is there. In the case of data mining, there is no operational data. In the case of database, the output will be precise subset of the database, whereas in the case of the data mining, the output will be a fuzzy type of thing, not a subset of the database. Query examples. For example, let us consider the query examples in the case of the database and data mining. In the case of the database, find all credit applicants with the last name Kumar. You can do this type of query. Whereas in the case of the data mining, find all credit applicants who are poor credit risk. It is called a kind of classification. In the case of the database, identify customers who have purchased more than Indian rupees 10,000 the last month. Whereas in the case of the data mining, identify customers with similar buying habits. This is called clustering. In the case of the query examples in database, find all customers who have purchased milk, whereas in data mining, find all items which are frequently purchased with milk. That is called association rule. So namely, you find in the case of the data mining, the classification rule is applied, the clustering rule is applied, association rule is applied. So the data mining models and tasks, if you look at the data mining, it has got predictive and descriptive. In the case of the predictive, you have the classification and regression, time series analysis and prediction. In the case of the descriptive, clustering, summarization, association rules, sequence discovery. Basic data mining tasks. Let us talk about the classification. It maps data into predefined groups or classes. Supervised learning is there, pattern recognition is possible, prediction technique you can do. And regression is used to map a data item to a real valued prediction variable. Clustering groups similar data together into cluster. It is unsupervised learning, segmentation and partitioning. Basic data mining task. Let us talk about the summarization. It maps data into subsets with associated simple descriptions in the form of characterization and generalization. Link analysis uncovers relationship among the data, affinity analysis, association rules, sequential analysis determines sequential patterns. The time series analysis, for example, the stock market is there. Today, what is the value? After 5 years and after, say, next week, what will be the value like that? You want to predict, the time series analysis is used. So, prediction for the future values. Determine similar patterns over time. Classify behavior. Data mining versus knowledge data discovery. Knowledge discovery in databases. It is called KDD process. Process of finding useful information and patterns in data. Data mining, use of algorithm to extract the information and patterns derived by the KDD process, derived by the knowledge discovery in database. KDD process, what it is exactly? The selection, obtain data from various sources, pre-processing, clean the data, and transformation, convert to a common format, transform to a new format. Data mining, obtain desired results. Interpretation and evaluation, present results to use in meaningful manner. So, the data mining development will be just like a star diagram. The information retrieval, statistics is applied, and machine learning is applied, algorithm is used, and databases are used. So, the star diagram gives you the data mining. For example, information retrieval is similarity measures, hierarchical clustering, and intellectual property type of systems, imprecise queries, textual data, and web search engines. In the case of statistics, Bayes' theorem is used, that is nothing but the conditional probability based on the theorem created by a famous statistician, namely Bayes. Regression analysis is used, EM algorithm is used, k-means clustering is used, time series is used. In the case of the machine learning, neural network is used, decision tree algorithms is used. In the case of algorithm design techniques, algorithm analysis, data structures. In the case of the databases, relational data model, SQL, association rule algorithms, data warehousing, scalability techniques. So this is about the star type of diagram on data mining. Now let us talk about the knowledge discovery data issues. It has got human interaction, overfitting, interpretation, visualization, large data sets, high dimensionality. And further, multimedia data, missing data, irrelevant data, noisy data, changing data, integration, application. All these things are used in the case of the KDD process. Data mining metrics. What are the metrics? The metrics: usefulness, return on investment, accuracy, space and time. Database perspective on data mining, scalability, real world data, updates, ease of use. So these are all very important. Visualization techniques, it can be through graphical, it can be through geometric, icon based or pixel based or a hierarchical manner. Database and OLAP systems, the schema, namely it is, you people might have already studied in database the physical schema and logical schema. So the identification, name, address, salary, job number, like schema. Data model, the ER and relational, transaction, query, again based on the SQL in the case of the database. Whereas in data mining, only imprecise query is possible. Like fuzzy sets and logic, they are used in data mining. Fuzzy set is nothing but is a set membership function in a real world function with output in the range, the closed interval 0 and 1. For example, f of x is the probability of x in f, you take that, it's a probability function of x. Then 1 minus f of x is the probability of x not in f actually. The domain f if you take, here 1 minus, because total probability is 1, so it is not in the domain f. So, for example, t is equal to the set of all x such that x is a person and x is tall. So, this is one set. You can say that it is a fuzzy set. Let f of x be the probability that x is tall. Then f is a member of the function because it satisfies this condition. Whereas in the case of the data mining, the prediction and classification are fuzzy. Fuzzy sets will be like this. Say for example, in crisp sets and fuzzy sets, you see the diagram here, short, medium, tall. In case of the heights, it is there. Whereas in the case of the height, the short, medium, tall, the fuzzy sets will be like the right hand side figure. Classification and prediction in fuzzy. Again, the loan amount is a loan amount and simple, and it is a simple actually, accepted region and reject region. Whereas in the case of fuzzy, it is accept and reject. Here you are having on the right hand side. Information retrieval. Information retrieval is retrieving desired information from the textual data. Library science, digital libraries, web search engines, traditionally keyword based, sample query, find all documents about data mining. So these are all examples of information retrieval. Whereas in the case of the data mining, similarity measures, mine text or web text will be there. IR information retrieval, query results measures and classification. If you look at the figure, information retrieval on the left side, the relevant retrieval, relevant not retrieval, not relevant retrieved, not relevant not returned. So all possible combinations are available here. On the classification side, the tall classified tall, tall classified not tall classified tall, not tall classified not tall. That is the classification. Now relational view of the data, if you look at, normally it is like a table type, the product ID, location ID, date, quantity and unit price. So if you make a table like that, simple table, that is a relational view. Next, let us think about the cubic view of the data. It is exactly a kind of the three-dimensional view, and it is as shown in the figure. You can present the data using a cubic view. Then aggregation on hierarchies. So it is nothing but a kind of the tree structure. A year contains month and season. Month contains day. Day contains hours and AM or PM. Hour contains minute and minute contains second. Similarly, if you take a company has got a product type, and product type will have a product. That is a product dimension, and this is called the time dimension. And similarly, a planet, if you take planet, country, continent, and a country will have state and region. State will have zip code and country. Region will have the city. So it is a location dimension. Star schema. And if the data is presented like this, it is called the star schema. So the product ID, day, and salesman ID, location ID, quantity, how many quantity is sold, unit price, like that. And from here separately it has got 4 subschemas. The product ID, that will have the attributes as description, type description. Salesman ID will have the attributes like department's demo, and division and divisional base, etc. like that. What is data warehousing? Data warehousing is subject oriented, integrated, time oriented, non-volatile, and the operational data used in day-to-day needs of the company. Information data supports other functions such as planning and forecasting. Data mining tools often access the data warehouses rather than operational data, whereas in the case of the data mining, may access data in warehouse. It is possible to access. And overlap operation. If you look at the figure, the single cell is there, multiple cell, and slicing. It is a slicing and the dice actually. Slicing is vertical and dice is horizontal cutting. So again, and roll up and drill down like that. If you look at the figure, it gives you very good visualization what is overlap operation. Now let us talk about how the statistics is used in your data science. Simple descriptive models, statistical inferences, generalizing a model created from a sample of data to the entire data set, exploratory data analysis. Data can actually drive the creation of the model. Opposite of traditional statistical view, data mining targeted to business user, whereas many data mining methods come from statistical techniques only. Pattern matching or pattern recognition. Pattern matching is nothing but the finding occurrences of a predefined pattern in the data. And say for example, I have got a set of data. I want to find out how many people are available in this set of data who cross 50 years. So you are finding a pattern, that is age cross 50 years like that. That is pattern matching. Applications include speech recognition, information retrieval, time series analysis. So it is called the type of classification in data mining. Data mining techniques again provide an overview of basic data mining techniques, namely statistical point estimation, models based summarization, Bayes theorem is used, hypothesis testing, regression and correlation, similarity measures, decision trees, neural networks, genetic algorithm. So these all the things are used in data mining, and these data mining techniques are applied in data science for getting the output results as your expected outcome. What is point estimation? Point estimates a population parameter, may be made by calculating the parameter for a sample, may be used to predict value for missing data. Example, R contains 100 employees, 99 have salary information. Mean salary of these is say $50,000. Use $50,000 as a value of remaining employees' salary. Is this a good idea? So this is called point estimation example. Estimation error. A difference between the expected and actual value. So I expect something, but actual value I get something. What is the difference? That is called bias. We call that bias. And expectation of theta minus theta. Mean squared error. The same thing when you make it expectation of expected minus your expected value and actual value, the square. That is called mean square data, because when you take the difference, sometimes it is possible to be positive or negative. So we square it. Why square? The root, then once you make a square, if it is negative, I can't take a root to mean square value. So we have to use root mean square value. Similarly, jackknife estimate is another formula. It is given like this as given in the slide. For the estimate mean of x containing the sample x1, x2, etc., xn. The maximum likelihood estimate is also used to obtain parameter estimates that maximize the probability that the sample data occurs for the specific model. Joint probability for observing the sample data by multiplying the individual probabilities, likelihood function. So then once you get it, the likelihood function of the sample x1, x2, etc. xn is nothing but the product of f of xi given the expected value theta, and when you maximize this, you get the output. Model based summarization, basically visualization, frequency distributions are used, mean, median, mode variances are used actually, box plots, and these are all applied as statistical measure. Similarly, scatter diagram, that is you are plotting the data in the form of the diagram, thereby using the curve fitting technique you can find out whether it is a linear regression or parabolic or hyperbola, etc., and based on that we can predict certain things. The Bayes theorem is nothing but the given probability is given, prior probability is given, Bayes theorem is applied and assigned probabilities of hypothesis in a given set of things, and here we are using the conditional probability. Say for example, the Bayes theorem is similar to this. Two boxes are containing red balls and white balls. A ball is taken from the first box and it is put into the second box. What is the probability to get a red ball from the second box? Like that. The similar problems, this Bayes theorem is used, and this is also used in terms of the data science for prediction of certain results. Then hypothesis testing. Find a model to explain behavior by creating and then testing hypothesis about the data. Exact opposite of usual data mining approach. Here null hypothesis we keep, hypothesis to be tested and alternative hypothesis. And this is also testing hypothesis. Here normally t test is also used, chi-square test is also used. So namely chi-square test is nothing but O is observed value, E is expected value based on the hypothesis. Then the difference bias we already told, square it given by the expected hypothesis, and if you make the chi-square and then if you get it, then we find that from the chi-square table and we find out what is the value. If it is less than that, then it falls on the 90% accepted region. If it is more than that, it falls in the rejected region. If it is falling in the accepted region, then using the chi-square test, your testing hypothesis is valid. If it is falling in rejected region, your testing hypothesis is not valid. Like that we do some data analysis, and so similarly the regression I have already told you. From the scatter diagram we can make a linear regression like y is equal to c0 plus c1 x1 plus etc. for x1, x2, etc. xn variables. Find the values to best fit of the data. So this is linear regression like this. And the residual difference, basically once you get a straight line, the residual difference, what we call the expected and the up and down, that difference will be sometimes, if it is above it is positive, if it is below it is negative, and that square we minimize, and thereby you get a linear regression. And correlation technique, again examine the formula using the formula of correlation coefficient, and you are doing some kind of testing analysis on the data. Data science is also done using the correlation technique. The distance measure is also used actually, is a distance between 2 points Ti and Tj, it is also used actually. And 20 question game is say, this is a very typical thing. If somebody is alive, yes or no, like the two answers you get. If no, where alive, then no, yes, like that. If yes, then person, who is that person, yes or no, like that. You go on analyzing. So this is called decision tree example. Similarly, a gender is there, whether it is a female or male. If it is male, what is the height? If it is female, what is the height, etc. like that. Go on searching like this, decision tree example. So like that, various statistical models and pattern recognition technique, correlation, regression, they're all, and as part of the data mining techniques we apply in data analysis. And so the data science is somewhat, you can say, is somewhat based on the data mining techniques, about 50 to 60%. And another 10-15%, the pattern recognition techniques they are using. They are also using some neural network techniques. They are also using some machine learning, etc. But majority, the data mining tools, in fact, the advanced study of the data mining techniques, I am not talking now. It is basically a introduction course to all of you, since it is a heterogeneous group of people. For more details, you can visit my site http://drsridhar.tripod.com. For your queries, you can also email to me to drsridhar@yahoo.com. Thank you very much.